Hey, good day, everybody. I wanted to go over some of these speed, velocity, and acceleration problems to make sure that everybody kind of understood the process for solving these. I get that for many people they are very simple, but in physics, word problems are something that we run into a lot, and so I wanted to make sure I go through at least 2 or 3 of these problems with you so that you can kind of see a model of how we can solve these things. So, from the assignment that I gave, let's take a look at number 1. Pete is driving down 7th Street. He drives 150 meters in 18 seconds. Assuming he does not speed up or slow down, what is his speed in meters per second? So one of the equations that I gave you is that speed is equal to a total change in distance, that's what the triangle stands for, it's change in distance, divided by a time, or a change in time. And we're going to use that equation to find Pete's speed. And so if I go ahead and kind of plug my numbers in, it says that Pete drives 150 meters in 18 seconds. Well, 150 meters, this is going to be a distance. And 18 seconds is most definitely a time. So if I go ahead and plug those in, I'm going to wind up with 150 divided by 18. So my total change in distance divided by time. And if I go ahead and just kind of plug that into a calculator, I'm going to find out that Pete travels at an average speed of about 8.33, and that is in meters per second, because I see that I have meters as one unit and I have seconds as my unit for time. So solving these problems is not difficult, but let's go ahead and try a different one. Let's try question number 2. A person jogs 4 kilometers in 32 minutes, then 2 kilometers in 22 minutes, and finally 1 kilometer in 16 minutes. What is the jogger's average speed in kilometers per minute? So again, I'm going to reference the equation that I gave for question number 1, that speed is going to be equal to my total change in distance divided by the total change in time. And let's go ahead and see if we can kind of plug some of these things together. So to solve for my total change in distance, I need to add up the 4 kilometers here, 2 kilometers here, and finally 1 kilometer. So I'm going to have 4 plus 2 plus 1, or a total of 7 kilometers of distance that got covered. And I'm dividing that by the total time that it took. In this case, and I'll highlight that in blue, I've got 32 minutes, 22 minutes, and 16 minutes. And so if I add up 32 plus 22 plus 16, I'm going to get a total of 70 minutes. So 32 plus 22 plus 16, so I've got 70 minutes. So I've got 7 kilometers that have been run in 70 minutes. And so if I go ahead and kind of do this math, I'm going to do 7 divided by 70. You can see what I've got here. I'm going to get a total of 0.1, and this is in kilometers per minute. Kilometers per minute. So this is the speed, average speed of the jogger for question 2. So those are 2 good examples of how to solve a speed problem. Let's take a look at an acceleration problem, because those are going to change just a little bit. So I'm going to skip ahead a little bit. I'm going to go to question 8. Okay, a roller coaster is moving at 25 meters per second at the bottom of a hill. 3 seconds later, it reaches the top of the hill, moving at 10 meters per second. What is the acceleration of the coaster? So the second equation that I gave you is that acceleration is equal to a change in speed, or a change in velocity, divided by, again, a change in time. So this is the equation we're going to be working with. Now, if I want to kind of write this out, so to include my numbers, I know that my roller coaster started at 25, because that is right here, and it reaches the hill 3 seconds later at 10. And I've got a time of 3 seconds. So I'm kind of identifying what my important information is. So if I want to figure out my change in time, I'm going to take my final speed minus my initial speed, and I'm going to divide that by the amount of time that it took, which was 3. So if I simplify this down, that's going to get me negative 15 at the top divided by 3. And so I'm going to wind up with an acceleration of negative 5, and that's going to be in meters per second squared, because I've got I'm talking about acceleration, so it's going to be per second squared. Now, before we move on to the next problem, I want to just kind of think about this. This is a negative number. My roller coaster is slowing down, so it's definitely experiencing negative acceleration. So anytime that you get a negative acceleration, that means that an object is slowing down, just like a positive acceleration would be an object speeding up. So if I have a starting speed of 25 and it ends at 10, this is definitely something that is slowing down. So that's how you can solve an acceleration problem. I hope that those examples were helpful. You should be able to complete all the problems on this assignment, and if you have any issues, please let me know. Have a good day.